Hello everybody and welcome back to a brand new tutorial on completing a GNS3 lab. Today we're doing a third set of labs that came from GNS3Vault. That's a nice website. You can sign up and get some cool labs from it. Today the lab we're going to be doing is under the CCNA routing and switching section, and this is the sequel. The last video was the ICND1 Assessment lab. Today we're doing the ICND2 Assessment lab. So get your popcorn, get your snacks, get comfortable, because this one probably will take a little while because the list of goals is much longer than the last one. And also it's a little bit more advanced, obviously, because it's ICND2. So we'll slide that over. We've got a nice little list of our goals here. Now the good thing is, unlike the last one, the ICND1, where we had to configure all the routers from scratch, these guys at least have a base configuration on them already, so they have their IP addresses and all of that's already in place. We're just going to be doing the advanced configuration, so moving it up a notch. So it lets us know on our goal list all IP addresses have been pre-configured as specified in the topology, so that's good. The very first thing we have to do is configure PPP encapsulation between Luke and HanSolo. So let's go look at our network diagram here. We have 3 routers all connected together. We have redundancy, and we have serial links using serial interface 00 and 01 on each one of these. We have our IP networks, the names for the hosts, and we have loopback interfaces on each one. Loopback 0, and they're 1111, 2222, 3333, which is good. That helps us identify the routers and ping them. So the very first step we'll do is between Luke and HanSolo. So I'll go to Luke first, and based on the network diagram we have in front of us, I can see I need to go to interface serial 01, and I just need to change the encapsulation to PPP. I'm going to go to HanSolo, interface serial 00, encapsulation PPP. So that's all set, and I'll do what we did last time as well. I'll go ahead and kind of mark these off as we go. So that's done for us. We just did this. The next thing it wants us to do is configure PPP CHAP authentication with the password of Vault. So we're not just doing the encapsulation. We're actually going to be taking advantage of one of the things the PPP encapsulation gives us, and that's authentication. So from here, I'm going to go PPP authentication, and we're going to be using CHAP authentication. So we just enabled CHAP authentication on both of those interfaces. What's going to happen though is it's going to go down because we don't have any authentication credentials. We need to give these routers a username and password to actually cross-reference. So we do that by creating a from global configuration. We need a username, and you need to give the name of the other router, the host name. So in this case, I'm on Luke. I need to give it the username of HanSolo. And the password, our lab wants us to use all uppercase Vault. So we have one side done. Let's go over to HanSolo, and we need to do a username. Luke password. Now that we have that up on both sides, our connection will come back up. So that you can see it just went up on its own. Also, I can see I need to do this real quick. I should have done this last video about following the lab instructions implicitly. Let's do line con 0 logging synchronous. Let's do that on all of the routers so we stop getting interrupted all the time while we're typing our commands. That'll be so much better. Alright, so we have our PPP CHAP authentication enabled and working because we saw our link come back up. Now we're going to be moving into a new routing protocol. We're going to be configuring OSPF on all routers, put everything in area 0, and that's your main backbone area for OSPF. And they give us some limitations. It says we can only use a single network statement on Luke, 2 network statements on HanSolo, 3 network statements on Chewbacca, and we cannot use the 000255 wildcard. So we'll go ahead and run through them in that order. We'll do Luke first. So we need to do router OSPF, and then we need to give it our process ID. It can be anything you want. It's only locally significant. I always use 1 as the common place. And just like the last video, the way I like to do routing protocols is do show IP interface brief. And this shows me all of my IP interfaces, and I can use that as a reference for my network statements. However, on Luke, they said using only 1. So it really doesn't matter what's on there. What I'm going to do is a network statement that would include every interface, no matter what its IP is. So the way that would work is I put zeros for my network, and I put an all 255 wildcard mask, which says it can be any IP address, and I need to state what area we're going to be in, which is area 0. So Luke's done. The next is HanSolo. So do show IP interface brief. Router OSPF network, and we're going to use 2 statements this time. So we'll say network 192.168.0.0. So I want to put the wildcard mask of 0, 0, 255, 255. So I'm saying the network needs to match 192 and 168 based on these 2 zeros. The 2 255s mean that I don't care what the last 2 octets are. It can be anything. If it matches, that will be added to the OSPF routing process. So that would match both of these networks. We need area 0. And then for the last one, and we got the adjacency already, network 3333, and I'm going to tell it to match all 4 of those exactly. So that means that network there will be included, and it's exclusive. It would only find that IP address on an interface and add it. Last is Chewbacca. We have to use 3 network statements. So and I'm just going to do it like this on all 3 of those interfaces. Now this right here, this method of putting a wildcard mask of all zeros is the Cisco preferred way. It is, I just see I made a mistake there too. I put a 16 instead of 168. Let's undo that first. This is the preferred way because then you won't accidentally ever include a network that you didn't mean to. Now in most cases you might be in a small environment wanting to include everything, and you can do that lazy single network statement we did on the very first router, but when you're in a bigger enterprise you want more finite control. You want to be a little bit more granular, so that's the way you want to do it. Another adjacency up, meaning we have adjacency on all 3 routers now, but we just need to make sure we include every network. Okay, so I just want to check my work here, and in case I made any more mistakes on an accident. It looks good. The way I would verify this is I would go to show IP OSPF interfaces, and I can look down here and I can see loopback, serial 1, serial 0. So all of those are included on Chewbacca. We can do the same thing on the other routers as well. So we can verify that we included all those interfaces with our network statements. So we can cross off that. Whole thing is done now. So that's gone. Ensure that we have reachability on every IP address. The easiest way to test that is, since we have those loopback interfaces, is just ping each one of them. 1111, 2222. So we have full connectivity, so that was easy and quick. Manually change the router ID on HanSolo to 222222. So we're still in our router config for OSPF. That's good, because this is where you'd put in the router ID command. And that's all you need to do to change the router ID. But it doesn't take effect since these neighborship are, see, someone else calls it neighborships. I don't like calling it that. Relationships, neighbor relationships have already been formed. They're not going to update themselves until you force it to, or a very significant amount of time has passed and calls them to update. So what I would want to do is do a clear IP OSPF process, and it's going to ask me to verify. This tears down the relationship, so this would interrupt your network if you did this on a production environment. But it forces those relationships to rebuild, and now it's going to update with that new information. So if I say show IP OSPF, actually let's just show IP protocols, I can see the router ID is 222222. So we've got that done. And you'd want to go clear that OSPF process on all the routers to make them actually update that new router ID. All right, traffic from HanSolo to Chewbacca should use the link between Router Luke and HanSolo. Use the bandwidth command to accomplish this. So we're going from HanSolo to Chewbacca, but it wants us to use this path, the longer path. So by default, the routing protocol is going to go with the shorter path. Open shortest path first. That's the name of the routing protocol. It has a lower cost. So what we're going to do is basically influence that cost by manually changing the bandwidth of a link. The easiest way to do this would be give this link a very slow bandwidth so that the combination of these two links is lower as far as the cost. So we'll do that. We'll go to HanSolo. First thing I'll do is I'll show the routing table, and I want to look for that loopback 111 interface, which is right here. And I can see that the next hop is 192.168.13.1. So there we go. There's the 13 network. We're verifying it's going this way. Want to check that first before we make changes. Now we'll go into interface. Serial 01, and I'm going to say IP OSPF bandwidth. Actually, I think it's just bandwidth. Okay. And I'm going to make it something really slow, like 10. Now, let's wait a few seconds. And let's look at our routing table. Going to 1111, the path is now 192.168.23.2. So it's using this link now. So we're going the longer way by influencing it. So we have done that. Next, it says remove the previous bandwidth command and now use cost to accomplish the same goal. So I'm just going to say no bandwidth 10. That resets everything. And now I'm going to say cost, and this is where it's going to be IP OSPF cost. There we go. And I'll use the question mark so you can see the range. After it does its calculations with its metrics, it comes out with the cost as the final value. And looking at the routing table here, you can see like 65 is the cost, 129 is the cost. The first number is the administrative distance. So as long as I can make this link cost more than the 192.168.23, which is down here, then we're going to have it change paths again. So let's say cost of 500. And right now it's still going through the 13 link as it hasn't updated yet. Let's keep checking it. And there you go, it already went through. So now it's now going down the 23 network. So that's how we accomplish that goal. And just out of curiosity, I want to see what our cost is while we're on here. 128, 129, 65. It's not going to show me because it's directly connected, unfortunately. Oh well. We'll go ahead and move on to the next one. That's done. Configure clear text authentication between Router Luke and HanSolo. So Luke, HanSolo, we'll go ahead and go to Luke first. This is going to be at the interface level. So clear text authentication. That would be interface is serial 01. IP authentication. IP OSPF authentication, because we're authenticating with the routing protocol. And we'll turn that on. There we go, that's turned on. Then IP OSPF authentication key, and that's where we actually put in our password. And it didn't tell us what to put, so we can put whatever we want. I have my Nikon camera in front of my keyboard, so that's the first thing that comes to mind. That'll bring down our link in a second. Let's hop over to HanSolo. Interface serial 00, IP OSPF authentication, IP OSPF authentication key, and that'll bring their link back up. It looks like we actually got to it fast enough. Oh, there it goes. Went down, then back up. So we saw that it went down and it came back up. So that's good. We've verified that is done. Next, we're going to up that authentication to a higher level. We're going to use MD5 authentication between HanSolo and Chewbacca. So we'll start with HanSolo. We're already there. We need to get to interface serial 01. So now the command has changed a little bit. It's going to be IP OSPF authentication, and then message digest. That turns on MD5 authentication. Then we have to do IP OSPF message digest key. Pick a key number. The key number does matter. It must be the same on both routers. And then MD5 algorithm, and then we put the actual password. So we'll do that again on Chewbacca. IP OSPF authentication, message digest, IP OSPF message digest key number 1, MD5 Nikon. And let's check out that we went down and we came back up, so we know that's working. We can cross that off our list. All right, next, change the OSPF hello timer on all routers so that the hello packets are sent every 6 seconds. Let's see here. So let's show IP OSPF interface. I just want to show you that the default is a hello of every 10 seconds, a dead timer of 40 seconds. So that way you can see the default values if you didn't know those. I'm going to take advantage of being in Super Putty and get everybody into global configuration mode. Because everyone's using serial interface 00 and 01, I'm actually going to issue a command to all 3 routers at the same time. So I'm going to say interface serial 0/0 IP OSPF hello interval of 6. And then we're going to say exit interface serial 0/1 IP OSPF hello interval of 6. And that's that. And I'm just going to show you real quick that it's IP OSPF hello interval, but I was just using some shorthand for that. And those commands carried through to all my routers because of the way I was issuing those commands. So we have that completed. We'll verify real quick. Show IP interfaces, and let's just look at the hello timer, and we can see it's now 6. All right, we can cross that guy off. Next, advertise a default route in OSPF on Router Luke. You are not allowed to create a static route. So we're not creating an actual static route manually, but we want to advertise a static route through OSPF. That's an easy thing to do. You just need to know the right command. So we need to go into router OSPF one, and we're going to do default information originate. So basically this router is the default route and the information is originating from this router. It's the original source, however you want to try to remember that in your head. But the big thing is the keyword here, always. If you type in default information originate by itself, it will pass a static default route to the other routers. But since we do not have a default route set, the always command is needed, the keyword, and that way it forces the other routers to, it forces this router to broadcast out that it has a default route even though we never set one. So if I look at the routing table of another router now, you'll see that we have an OSPF default route being broadcast out and sent to the other routers, and it's going to be going towards Luke, so whichever way Luke is. That's how you handle that. So that's done. Alright, next is an optional step. If you look at the routing table on any router, you'll see that the loopback interfaces are advertised as /32. Please change this to reflect its real subnet mask that you have configured on the loopback interface. I actually have the routing table here. You can see that these loopback interfaces are /32s. That's the default behavior in OSPF for a loopback interface. And the reason why that happens, and we'll go back to the same command I showed you earlier. So we're going to say show IP OSPF interface. Look at the network type. So here is a point-to-point network. Here is a loopback network. It's a feature of the loopback network type. So what you would do is actually change that. So we'll go into interface loopback 0, and I'll say IP OSPF network point to point, and you can change it to something different, but point to point is what I would change it to. And now this was the router with the 222 loopbacks. Let's do a do show IP route, and we'll look at our 222, and you'll see that it's now advertised with its /24 subnet mask instead of the /32. So that's how you would accomplish that. Next is asking us to configure RIP version 2 between Luke and Chewbacca, and it wants us to advertise the loopback interfaces. So we'll start with Luke, and to get to Chewbacca we're going through serial 0/0. So I'm going to do a do show IP interface brief so I can see my IP address for that link, and I'm going to say router RIP version 2, no auto summary, and then I'm going to make my network statement. We need 192.168.12, and we need the loopback. So that's completed on Luke. We're now going to Chewbacca. Chewbacca uses serial 00, so we need the 168.12 network. So router RIP version 2, no auto, network 192.168.12, and network 1. And show IP protocols. We can verify through here. RIP is routing for both of those interfaces, so we have that up and going. Next it says ensure that you see the RIP routes in the routing table for the loopback interfaces 111 and 222. You are not allowed to make any changes to OSPF to make that happen. So let's go back to our routing table. Whoop, that was not what I meant to do. Okay, so I'm looking for the RIP routes, and they're actually already in my routing table. But I know what the lab is looking for. It's looking for, you have multiple routing protocols running right now. OSPF has a default administrative distance of 110, while RIP has a default administrative distance of 120. So it's going to prefer this route. It's more believable, and it would supersede and just totally annihilate the RIP route. But what you would want to do to make the RIP route take precedence over that is change the default administrative distance to something lower than 110. So even though I don't have to do it in my example, I'll go ahead and show you how to do it. So we would go router RIP, and let's see, it's default. No, it's distance. And then you just change it to a default administrative distance. I'll put 80. I'll do it on both Chewbacca and Luke. And now we'll go back over here and look at our routing table until that updates. So we're looking, there it already changed. So now the administrative distance is 80, which is more preferable to the 110. So if these routes were being suppressed, they would now actually be showing up. That was done. Okay, next, when you type debug IP RIP on router Luke, you'll notice that it's sending updates towards the loopback interface. This makes no sense, so fix it so that it will not send updates while still advertising the network. I'll go ahead and do what the lab tells us to do. I'll type in debug RIP, debug IP RIP. So I don't have to turn this on to know that's what's going to happen, because the network statement itself, what it does is two things. It says what interfaces are going to be included in my network advertisements, as in I will tell other routers about them, and it also says what interfaces will I be sending these updates out to. Since we're including the serial 00 and the loopback 0 interface, we're advertising about both of them, but we're advertising to both of them. So let's go ahead and say undebug, turn off debugging. And the way you fix this is easy, and it's a good standard practice to have this on a production environment. We'll go into global config, router RIP. We want a passive interface, and we're going to put the name of that interface, so loopback 0. Now we're still going to advertise that network, but we're not sending the advertisements to that interface. So that's easy, and that's fixed. Now we're moving into yet another routing protocol. Configure EIGRP between router Chewbacca and HanSolo. Advertise the loopback interfaces as well. So we'll go to Chewbacca first. And we're going from Chewbacca to HanSolo, so we're using this link here. And that means we're going to be using the serial 01 interface. So I'm going to say do show IP interface brief. And serial 01 is our 13 network. And I know we do have our network diagram here, but this is how I would verify things. It helps it stick in my head. So I'm going to say router EIGRP. And then you have to put the autonomous system number. And unlike OSPF, where it's only locally significant, EIGRP is globally significant. If other routers are not using the same AS number, then they don't communicate. So we need to make sure that that is the same on every router. So we've enabled it, and now we need to do our network statements. And EIGRP is really interesting in that it kind of works like a hybrid between OSPF and RIP. You still use the network statement, but you can do a RIP type statement. So I can say, for this case, we're using serial 01. So we need the 192.168.13 network. I can say it just like that, and it'll take it. Or I can do like a OSPF type statement, say network 1111 with a wildcard mask of 000. It'll take that as well. So let's go verify. We'll do a show IP EIGRP, and we'll look at the interfaces. And I can see that loopback 0 and serial 01 are included in that EIGRP setting, so that's good. Moving on to HanSolo. We want serial 01, which is our 13 network, so we're going to go router, EIGRP, autonomous system 1, network 3333, and network 192.168.13. So we have EIGRP configured, and you get to see that the neighbor relation just came up and we have a new adjacency, so we know that's working. So we can cross that out. Now, next, create 2 additional loopback addresses, one for Chewbacca and one for HanSolo. These are loopback interface 1. So we'll start with HanSolo since we're already on this router. So we'll say interface loopback 1. IP address is 172.16.2.1, and it's a 24-bit subnet mask. On Chewbacca, we want interface loopback 1, IP address 172.16.1.1, 24-bit subnet mask. All right, so that's done. And cross that off. Next, it says advertise the loopback 1 interface on HanSolo and EIGRP. So we're going to go back to router EIGRP system 1 network, and it is 172.16.2.1. So that's done. And we'll even verify, so we'll do a do show IP EIGRP interface. Yeah, loopback 0, loopback 1, serial 01. All those are done. Next it says ping 172.16.2.1 from router Chewbacca. Make sure the ping works, and if not, check your EIGRP configuration. So we need to go to Chewbacca, and it wants us to ping 172.16.2.1, and it was successful, so that step's complete. We were just fine. The next says ping 172.16.1.1 from router Chewbacca, but this time make sure that the source ping address is the loopback 1 interface. Does it work or fail? Why could it be different that you are pinging from the loopback 1 interface? So the way you do that is ping, but then you type in the source keyword, and then the interface we want, loopback 1. And that ping is failing. Now, I'm pretty sure that most of you already know why, because the lab only had us add a single loopback interface to the EIGRP routing system. So therefore, the other router doesn't know about this interface and doesn't know how to reach it. So all we need to do is go into add it. So we'll go router EIGRP 1 network 172.16.1.1. Now let's try it again. And it's not working. I know why, and I'll go ahead and explain it to you guys. And this is why I have a best practice of always using no auto summary on everything I do. If you look at the IP addresses, this is like a trap that they gave us. They gave us 172.16.something.something addresses. Those are Class B addresses. So that means by default they get a 16-bit subnet mask. And that means that between those two routers, if they're summarized to the same, they're falling under the same network, and they won't have their own individual routes. So if I'm sending something to that address, it's going to go into null 0, which is the bit bucket. That's the hole of death. All you have to do to fix this is go into EIGRP and say no auto, just like we did with RIP. Because EIGRP is a classful routing protocol, and you want to always use no auto, in my opinion. So we have it done on one side, we need to do it on the other as well. Now I'm going to go back and I'm just going to try the same ping as before. And it's working. So that's the reason why that was not working. Alright, next is change the configuration on Router HanSolo and Chewbacca so that reliability is used as a metric. Now this is very, very advanced. I don't even think this is ICND2. This is like CCNP or even higher. You would never in a production environment want to mess with metrics, I don't think, at least not in my experience. But there is a very complicated formula about how this works. I have the Cisco page up here that kind of explains the formula. It's bandwidth times this divided by bandwidth plus 256 minus load, blah, blah, blah. Well, that's all these K values. There's 5 of them, and the K values, by default, K1 and K3 equal to 1. And that means you're just using bandwidth and delay. K2, 4, and 5 equals 0, which means you're not using reliability, you're not using a few of these other values. So what we want to do is go change that default metric calculation to include reliability. So reliability is the K, let's see, because I don't have these memorized, I never do this. We have bandwidth and delay. K2, I know it's not K5. I wish I had a little cheat sheet. Let's see. We'll go in there and we'll find it out. So from one of the EIGRP routers, we can go to global config router EIGRP1. And just do this real quick. Default metric. This is not the command we want to use to actually do the lab question, but it's going to tell me what the K values are. So K1 is bandwidth, K2 is delay, K3 is reliability, and that's the one they wanted us to add in there. So it's K3 that we're adding. K4 is the something about default. I don't even know what it is. So K3 is the one we want to turn on. So let's go into metric and weights. So K1 is supposed to be on, K2 is going to be on, hold on, getting confused. Type of service. Okay. So weights K1 on, K2 on, K3 on, K4 off, K5 off. That's what we're doing. And that's going to tear down all of our neighbors. So we'll go back over to the other router that we're working with. And my cat's saying hello to everybody. Okay, so we'll go. Plug in the same metric weights, and everything should come back up. So that's complete. Very last thing in our lab is configure authentication for EIGRP. It wants us to use keychain name vault, the first key, key ID 1, and the string is going to be welcome. So let's go ahead and configure that. From Chewbacca. we're going to create a key chain. The name of it is vault. And now it's asking us for the key ID. And then we need the key string. And the actual string is welcome. This is when the question mark really comes in handy for setting that up. So we have that done. On the key chain is created. Now we need to go to the interface. We're on Chewbacca, going to HanSolo, so that's serial 01. It's going to be IP EIGRP. No, I'm sorry, it's going to be IP authentication mode EIGRP 1. I don't think that we do want MD5. So there we go. IP authentication mode EIGRP1 MD5. Then it's going to be IP authentication keychain EIGRP autonomous system 1, and then the name of the keychain is vault. Now let's go copy that over on HanSolo and see if we bring ourselves back up. So we need interface serial. Actually, let's do our keychain first. Key chain and VAULT, and then we want the key 1, key string, and it is welcome. So our keychain's done. Interface serial 01, IP authentication, EIGRP. Okay, mode, EIGRP, autonomous system 1, MD5, IP authentication, key chain, EIGRP, autonomous system 1. Okay, that should be everything. It should come back up if I did that right. There we go. New adjacency. We were able to configure that properly. And that completes the lab. So I hope you guys enjoyed that lab. That one was pretty in-depth. That's about where my skill level is at right now as far as testing and learning. So this one was a good refresher for me. Hope you all enjoyed the video, found it educational and entertaining. Remember, if there's anything I can do better in the videos to make them more entertaining, to make them more educational, just let me know in the comments. Hope you appreciate it. I definitely appreciate all the thumbs up and likes and things. I just want to remind you guys that this was Vicious, and I'll see you next time.